So, of course, the weekend of the 40-year festival of 1982 in Cambridge Centre for Computing History, I'd bought on eBay a punch, as you can see above me, a Facit N4000 chatter pickup from Horsham. And I thought, I'm going to get there reasonably early in the morning. Might as well take a jump over to Ramsgate as well and have a look at the this museum is not obsolete. Unfortunately, by the time I dealt with it and had a good chat to the guy who's getting the Facit from, because he's got a great collection of machines and background, yeah, it was getting late and the traffic was such that Ramsgate would have been impossible. So I abandoned that travel over to there to see the museum and went straight up to Cambridge. So hopefully you will have either already seen or will see the coverage of the festival, which is great fun. I did see the machine working. It punches. It's got no CHAD box on it, and we got another problem as well. But it does punch, but the reader was marked as faulty. Display works. It hasn't got the code stuck on it, which the custom firmware that GMC Precision had on their restoration video. I put a link in the video below on that one, which is what originally set me off on the idea of getting one of these. As I say, the reader head we'll take a look at in a bit more detail. The CHAD box isn't present, and here's the tape, which is shown here correctly spooled, although when I picked the machine up the tape wasn't correctly spooled, I don't think. So we've got the RS-232 inputs as well and outputs there. Both, there's two channels, it can handle both. I'm using this one over on the left at the moment. The user manuals are available on BitSaver, as is the service manual, and someone's hand-drawn a great circuit diagram and board layout, which is really useful. So these date from the 80s. I think this manual is actually from 89, so that they're quite some of the last punch devices built for use in CNC machining and that, but pretty good rate of operation, 75 characters per second, which is quite good going. Good variety on the RS-232 as well. I've got mine set to 9600 at the moment. So we should be programmed. We'll do a little bit of a show and tell of the whole entire machine when it's all running. Hopefully we'll take a quick look here at this point, perhaps of it just punching something out of the tape and how it is correctly wired, and you'll see. So I did rethread it. As you know, when I received it, it was this way round, but it actually goes there, comes off, goes round that one, back round that, and down there, and into the side. So just a quick view. This is the CHAD box I've made just briefly. So I've got a box that fits in there, and I've made a temporary chute just as a slot on the bottom. So as you can see from there where the punch comes in, it sprays out there. So we'll give it a go. Just put that CHAD box back on there, just to take the worst of the stress. Power the machine up. Comes on local. This if I go online, and I bring up my terminal in the screen here, and I just type 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then with caps lock on, maybe A, B, C, D, E, F, G, H, I, J, K, L, M, N, Q, R, S, T, V, W, X, Y, Z. And you can see it's jamming up slightly because that didn't have that thing. If I go back offline and I do a little bit of a feed, then we've got the tape now. You can see what it has started there for each of the numbers and A to Z on a little bit of tape. So that's the temporary CHAD box running and feeding the CHAD down into my cardboard. I'll come up with something more permanent longer term. So this photo from the Crypto Museum's handy. It shows the actual inside of the box as it would have been. So you can see the where on mine all the foam has gone. But you can also see there's a missing plastic guide here, which is what allows the tape to come out to the side properly. It's got a little curve on it, I think, here, which is why it's jamming occasionally. And this is the key. This is the little chute that has got an angle piece that takes it over to where the Chad box fits in the front. And obviously this one's also got a fairly significant earth strap all the way down, although mine's got an alternate with these two fairly heavy duty connected earth connectors. It's really down now to see what was wrong with the head. So basically the reader doesn't work, so I've unscrewed the 4 screws on the front and I'm pulling off. You can see all the chat on the floor where it's making a right mess. So the reader, these just unplug quite easily. And laid out on the bench, then I've unplugged the motor drive here and undone the 2 screws which are captive, but laid the board out. You can see I've got some test tape in there with some reader values on it, and a bit of a close-up of the bottom board with, I believe this is the transistor that's driving the lamps. And here's the back of the second board and the front of it. None of the tantalum seem to be blown, so it's something I looked at first. I'll check all the diodes as well offline. And this is the actual reader head removed. There's 3 screws in the back that take the cover, rather. There's a little plastic cover on it, and 3 screws that hold it in. This roller here is actually designed to go inside of the head to allow this weighty clip to work. I managed to lose that because it popped out when I lifted it too hard. So here's my first attempt to work out why maybe extracting the lamp. And it does look like a break here, but when you measure the resistance, that is 3.9 ohms. So I wonder if it's just an artifact of the photography. It's very difficult to get in with a microscope. You can see it's a bit difficult. And this is the sort of prism arrangement. So here's the light going down on the steps. So the lamp is in here, and this is the lamp for the tape detect, I think, rather than the holes for the sensors. So this is the tape detect sensor, like I say, which goes underneath here, but in this photo you can see it does look like it's all in one piece. And here's the lamp that illuminates the feed. It's going to need a good clean as well. It goes down through the various holes in the head. So they couldn't see any obvious physical things to the boards, as I said, and it's pretty much down to what the heck's going on now when the reader's not working, because it just doesn't light up. So first steps then, let's get a scope on some of the parts and take a look, shall we? So apologies for the racket. Obviously the fan in the punch is quite loud. Just the head's completely stripped out now, and I am down in the bottom corner here monitoring 2 lines on the scope. The yellow is the not read direction, I believe, and the blue is going to be read step. So basically there is a button on the keyboard which is read is the direction of flow, forward or feed forward and feed back, which are on the 1 and 2 keys, I believe. So if I do a feed forward and press it, you'll see that the level changes up to 5 volts, and if I do a feed backwards, the level drops back down. So the changeover for read direction on the yellow is actually working. So we've obviously got no lit light for any, but it is a multimeter shows just about 3.9 ohms on both lamps, so I don't know why they're not lit. And we've definitely got 12 volts on the connector here at the far left. I think it's only 12 volts. That's interesting. It's supposed to be 24 volts. Let's just check, shall we? If I've got the channel set to 5 volts per division on yellow, that's 5 volts per division now. So I'll move the yellow test probe to the front, and oh yeah, we have got 5, 10, 15, 20, 25 volts. That's fine. So it is correct, and we've only got 5 volts on the, yeah. Okay, yeah, that is right. a 5-volt run and 24 volts. Okay, well there goes another theory then, but that's good news that the direction, which means the hookup to the digital board, is running, and with the 2 buttons I can flick between forward and backward. And that voltage set it to 2 volts. That's actually only getting up to about 3 volts, isn't it, from the yellow base point? Well, that could be a problem then. For completeness, we'll check the other lines, which are read data. This is read data 0 on this point, I think, down here. That is 0, and read data 1. I would expect all these to be. Read data 1 is a 0, just a small voltage on it. Oh, read data 2 is up at 5 volts. Interesting. RDSTB, whatever that is that's that one after the pin. That's got a little bit of noise on it on the yellow. And then we've got read data 3, which is 5 volts. Read data, a little bit of signal on read data 4. Read data 5 is 5 volts. Read data 6 is 5 volts. Read data 7 is 5 volts. And top sense is 0. So we've actually got data coming out of the data feeds, but no lamp and feed. Maybe that's coming from the colour, from the actual lighting. Oh, so let's read data 2, I think, add 5 volt on it. Let's see if screwing the sensors change the light. Oh, just out of interest. No, didn't think it would, but interestingly, it probably needs to move to latch. Okay, well, got a little bit more information about the machine. So this is the board layout we've got from the online bit savers. We can see the read head and the tape sensor. As I said, it was the read direction here which goes up and down, although it does only get up to 3 and a bit volts, which I'm not sure. Read step doesn't seem to move, and obviously motor run just stays at 0 volts, but we've got 24 volts and we've got plus 5 volts. So is the reason the read is not running because the motor run's not happening? Don't know. And we got a variety of fixed outputs from the read data lines. Nothing from tape sense, that's 0, and this read STB, not sure what that is. So this is the circuit diagram apparently of the reader head. I think there's a couple of read data latch as well. So I'm assuming that's what we're seeing out of the data. It's probably just some random data locked into the latch when it was turned on. And we've also got the stepper motor counter, stepper motor enable. So this is where the motor run signal is coming in for enabling the motor. If it's sat at 0, then it's not going to turn that transistor, the motor's not going to run. So it looks like maybe we're not getting the digital signal for motor run. I'm not sure where iSense goes to elsewhere on the organic. So here's this read direction and step. And step A and step B, read direction, going into the stepper motor controller. So, just looking at this now, it's the read head output. How do the lamps run? Well, both lamps, by the looks of it, I've got a 10 ohm resistance. So between test points 1 and 1, I should have the resistances of the lamps. Like I said, with the lamps in circuit, I'm getting about 3.9 ohms, but that could be I'm getting it through only one lamp and not the other. But because they're in parallel, if one of the lamps is working, it should be working. So, not sure why they're not. I have to assume we're going to need to look in this Q1, this BC548, make sure it's got 5 volt on its collector, and maybe take a look at its voltage is coming down from the 24 volt line turning on, so it's possible if this transistor's blown the lamps won't work. So what we need to do is have a little probe around, I think, around Q1, which was on the, I was quite right, it's that transistor up in the top corner. See if I can get in there and have a little look at what's happening with the base of the transistor. Sorry, wrong one, that one, yeah. So I need to get a look at this base of this transistor and see what voltage is on there. But it looks like they should be on permanently. It doesn't seem to be controlled in any way. No, I'm drawing a blank. So I think what we're going to do is measure the voltage at the base of the transistors. Let's find a pin out for the BC548 and check it. So as you can see, the blue line is a 0 and so is the yellow. And that means that we have nothing on the collector of this transistor. It should be receiving 5 volts. Now, is that because it's somehow grounding it? But that would make the lights light, I would have thought. And if I try and get a... Nothing on the base either. Funny. Well, taking a look at that, oops, can't see the screen with these on. It looks like I've got nothing at the collector and nothing on the base either, judging by this. So going back to that diagram, if I've got nothing at the collector, then I haven't got my 20. If I've got nothing in the collector, I should have 5 volts on the collector, but I haven't. So I would have thought I'd have seen that at least, but I don't. I'm 99% certain that is Q1. Actually, doing some static testing, if I light it up a little bit better, you can see actually Q1 is that transistor there, not this one, which is what I was using initially to test for. So I need to actually have a little look at the layout connections and values that we see when it's powered up on that side. So let's have another little look to see if I'm getting the voltages on that Q1 transistor I was expecting. Got to be really careful, it's quite tight to get under there, under the head, but let's have a little look. Well, on that base of that transistor Q1, I'm seeing about 1 volt. But on the collector I haven't got 5 volts, so that should be enough to forward bias it. Quite why they've got all this complexity for biasing the transistor, I don't know. But I don't know 5 volt on the collector, so I'm going to have to investigate why that isn't happening, because obviously with no 5 volt on the collector we'll have a problem, but there's nothing else in the circuit. Bit of a mystery. I'll have a little good look offline now and see what we're doing. So I did some static tracing of the board, and in fact the eagle-eyed of you will spot the fault already when I've illuminated the baseboard from the back while I was tapping through and tracing lines why I wasn't getting that 5 volt. I had a good look over the board and into the sensor board as well. These are the resistors coming off the photo transistors on the light sensor. Obviously I've put the cover back on the base. And if you look very carefully, the board's got some scratch damage here. It looks like something's maybe drawn, maybe even consciously tried. When you look in deep, you can see there is a break in this line, and sure enough, this line, this is the 24 volt, this is the 5 volt, and this is the ground. Now it's obvious that that 5 volt's supposed to go there, so I thought maybe someone had been trying to diagnose a fault on a 5 volt line and had cut the trace in order to see where the fault was. So I did an ohmmeter test, and it wasn't shorted out between ground and 5 volt here, and between here and here it wasn't either. So I joined that link with a wire link back up. And there we go, we've got a light on, and if I do the back, oops. Oh, I've got an error. I got the tape in inside out that way. Think right? Yeah, it should be that way probably. So there we go. load the tape in the right way. So I think the tape goes that way. So if I haven't screwed that back on yet, but I think that's there. So in theory, I should be able to do back and forth. There you go. And it knows when there's a tape in there. Okay, so it works. That is enough weight just with itself, not the spring, to do it. Job done. I fixed it. It was just our 5-volt line cut for some reason. Maybe something heavy had been dropped inside and broken it. So seems to be going. We've got an error on the display, but after we screw this housing back on, put the reader back into the actual casing maybe, and we'll give it a go, see what happens. Success, we might be able to read a tape. Excellent. It's quite late at night now, as you might guess, so I had a bit of tea and had another play with it. And if I run the test tape through the reader, it's online at the moment, I press the start button, I've got an error, and then the 4 question mark. So I got different data this time to last time. Well, that's a shame. Let's try it again. I went right through this time before I got the error, but it's still reading random, almost random data. What I did do was, if we take a look at this image, I basically copied my test tape, and as you can see, there's some these bits are always a 1, which they seem to be there, except so that might be okay. There's no bits for these 2 bits here at all. This is an error, I don't know where that came from. These are the aligned ones. We've got this bit 0 seems to be correct. Ignore if you ignore that random one. Bit 1 is not correct because it's set there. It's set there, and it's also set there. So I thought, oh, it's always a 1, but actually it's not set there. So it looks like that's random. But we have got some bits correctly set, I think, there, and this one I think is correct that it is set, but this is not. This is missing. So there's definitely some of the bits are not getting the right data. So I think we're going to have a bit more investigation another day on that, what's happening with the output from the head. Thinking about it in that circuit diagram, I suspect the complexity here with the diodes and the resistors is to set a very accurate forward bias for the transistor in order to adjust the brightness of those bulbs. I'm suspecting that's what it is. It's got to be something around that, hasn't it? But anyway, at least we're making progress, and we've got some data coming out now. So these phototransistors are returning data. So I think maybe I need to have a dig and see what is actually coming out from each one of these with some known tape data on. So I'll have to punch a tape with some known figures cascading up from 0 maybe on each bit, because that's actually got 1, 2, 3, 4, 5, 6, 7. Is it 1? No, 1, 2, 3, 4, 5, 6, 7. Yeah, okay. So it's actually got a full 8-bit read. That looks at it. That's unusual. Now this one, this is just this is something else. This is to read the center sprocket hole only. That's definitely what it is. So that center one is the sprocket hole read, I think. So that's that would explain why we've got the extra bit. So it is actually only reading 7 bits of data but you've got the sprocket hole for when it triggers, which is, and they've obviously got the tape sensor here with that knows that there's tape sense, which must be working pretty much. On maybe the error we're getting is the tape sensor incorrectly triggering. We'd have to have a little look at what stick the scope probably on the tape sense outline and see if every time we get an error it's the tape sense that's changing status. Maybe try and capture it. We'll have a little look. It's going to need some more diagnostics and maybe even a logic analyzer so we can trace exactly what's happening to some of the signals. Oh well, back on it tomorrow then. I'm Tim Gilbert, and this is my channel on retro computing.